If you want to build your own question and answer system on your own data, is it possible? Well, yes, it is possible. So you can use Langchain and OpenAI APIs for building your own question and answer system. So in today's video, what we would do is we would first discuss the architecture of the question and answer system, and then we would build our own question and answer system using Python. So let's get started. Subscribe to our channel for more content related to Python, data science, machine learning, and AI. So this is how the architecture of question and answer system would look like. So in the first stage, you have to load all the documents on which you want to create a question and answer system. Suppose you have set of PDFs, let's say you have 100 PDF files, and on those PDF files you want to create question and answer system. So all those PDF files you have to load in the first stage. So in this stage, all the PDFs are loaded. Then after you load those PDFs, in the second stage, basically you have to do splitting. Now what is splitting? So each PDF file would have thousands of characters, right? Maybe say 150,000 characters or 1 lakh characters. Depends on the size of that file, right? But in splitting stage, what you do is you break down your PDFs into small chunks. So basically into small splits of set of rows, and then you create number of splits based on the PDFs that you have provided. So in the splitting stage, you break down your PDFs into small splits. For example, splits of 1000 characters each. So those would be then your set of rows which represent each split. So instead of using all PDF, you can use those splits for the next steps. So once you create those splits, the next step is converting those splits into embeddings and storing those into a vector store. Now what is embedding? So if you look at any machine learning system, it won't be able to understand text on its own. So it always converts that text into a numerical format and it understands the numbers. So in the embeddings, what happens is the splits which we have created, we convert those splits into a numerical format. So suppose we have created 5000 splits, then we would create embeddings for those 5000 splits, and those 5000 would become our vector representation of each split. And those 5000 embeddings then we would be storing in a vector store. Then once we do that, the next step is creating a retrieval system. So what happens in this case is whenever we ask any question to our system, what it would do is it would first convert our question as well into embedding, and then it would compare the embedding of a question with all embeddings that we have stored in a vector store, and then it would return us top similar embeddings, suppose top 5 similar embeddings based on our question. So that would be based on is it finding any data points or any text which is similar to the question in those splits which we have created. So those relevant splits or relevant embeddings are written, and in the next stage what happens is this question and the relevant splits, it's converted to a prompt to a large language model. So this is then converted to a prompt to large language model. So if we give question and relevant splits data to large language model in the form of prompt, it would return us answer. So basically if we tell that this is the question and these are my most relevant splits, can you give me answer for this question? It would be able to give answer to us using the large language model. So this is how overall question and answer system works. So this is the architecture of question and answer system. What we would do now is we would build this system using Python, using our own data, and I'm very sure that after you follow these guidelines, you would be able to build your own question and answer system as well on your own data. So what we would do is we would use the Langchain framework for building our question and answer system. So in my Python code, what I'm doing is I'm importing all the modules and functions that we need from Langchain framework at the top. So all the things that we need. So basically for loading the documents, creating a retrieval system, we are loading all those things from Langchain framework. Then the first step, if you remember the architecture, is loading the PDF documents. Okay. So this is the first step. We want to load all the documents for which we want to create a question and answer system. So what I'm doing is I'm going to create question and answer system on 2 documents. So the first document is a technical report published by Google DeepMind. So it is a report related to a Gemini performance. So related to how Gemini works, different kinds of models in Gemini and its performance on various benchmarks. So that technical report I'm going to use as the first set of document. And the second PDF that I'm using is related to the large vision models. So this is again a research paper published related to large vision models, which can be built on image and video data. So this is the second research paper that we are using. So we are building question and answer system on these 2 PDFs. Obviously, if you want to build your own question and answer system on your own data, you can use those PDFs as well. So the first step that we would do is we would load those PDFs using the directory loader function from Langchain. So this is the path where my PDFs are stored. So you can also give your path where your PDFs are stored, and in that path you can keep the PDFs on which you are going to create a question and answer system. So when you do this directory loading operation, you might get an issues with respect to the package unavailability. So you have to install the unstructured PDF package for this, and you would also have to update the environment variable. So when you do the package installation, you will get proper warning. So make sure that you do those steps, because only then this code is going to work. So in the first step, we have now loaded the PDFs on which we want to create a question and answer system. Now the second step is splitting those PDF documents into chunks or splits. This is what we would do in the second step. So for that, we are going to use character text splitter from Langchain. And to character text splitter, we are saying that use separator new line. Then the chunk size that we are saying is 1000 characters. So create chunks which would be of 1000 characters. And we are saying that also allow overlap of 200 characters. So this is how we are defining a character text splitter. So if we run this code, it would be able to split our data into chunks. So let's run this. Okay, so you can see here it has converted data into chunks, and some of the chunks are having size greater than 1000 as well. Now why this happens? So basically character text splitter is designed in such a way that it is going to create those splits where the row is not going to get broken in between. So suppose in first 1000 character, it considered the 8 rows, right? And there is a 9th row as well, which is part of the 1000 characters. So instead of breaking that row, it would consider that 9th row or 9th sentence completely. And even if that increases the size of chunk or decreases the size of chunk with respect to recommended value of 1000, it doesn't care about that. The main focus it has is let's not break the sentences into different chunks, because if you do that, that might not be an optimized way in converting your chunks into embeddings. So basically that's why we would get chunks which might not be exactly of size 1000. So now in this text, we would be having chunks. So in text, we have 272 splits which we have created. So let's try to see if we have data in that. So let me open this. So this is our first split. So it is of size 979 characters, and this is the data it has. So if you see here, it has taken the data from start to end, and again the priority is given to make sure that the chunks are not having broken sentences. What is our second split that we have? So let's check this. So this is the second split that we have, and its size is 826 characters. If we open it, this is the data basically. So if you see this, again it is ending at the end of sentence. So even if that reduces the chunk size, it is not caring about that. The priority is given to creating chunks where the complete sentence is present in chunks and it's not getting broken. So this is how now we have converted our data into splits. So we have created 272 splits from the 2 PDFs which we have loaded. Now the next step is we have to convert those splits into embeddings. So the next step is converting those splits into embeddings. So for that, what we would do is, first of all, we would get our OpenAI API key. So this OpenAI API key you would get by creating your own account on OpenAI API website. So there you have to create your own account, provide your credit card details, and there you would get your API key. So what I have done is I have stored my API key as an environment variable, and that's why I'm able to load that using the OS environment get function. So I'm loading my environment variable into a OpenAI API key. And then we are using the OpenAI embeddings functions from Langchain. This would be useful for us for converting our splits into the embeddings. Then for creating a vector database, we are using FAISS package. So this package is basically created by Facebook. It is called as Facebook AI Similarity Search. So it is created for developers only. So this is the optimized way for doing similar embedding search. Because if you remember the architecture, right, for any question that we are going to get, we want to search the similar embeddings from the splits that we have, right? So for that operation, this package would be useful. So we are creating a vector database using that package, and to it we are passing our splits and the embedding objects that we have created over here using OpenAI embeddings. And then we are defining the large language model again using OpenAI, and to it we are passing our OpenAI API key, because these models won't work without a API key because they have to charge you based on your usage, right? That's why you need to provide the correct API key. So in this stage, basically what we have done is we have converted our splits into embeddings, and now the next stage is creating a retrieval QA system. So what we do here is we define a retrieval QA system again based on the Langchain model, and to it we pass the large language model which we have initiated over here. Then we define chain type at stuff. Now what is chain type at stuff? So basically what this system would do is whenever we ask any question to this system, it would first convert that question into embeddings, and then it would return similar embeddings by comparing the embedding of a question with embedding of the splits that we have. And once it gets those similar embeddings, it converts our question and the similar splits into prompt. So that is converted to a prompt for large language model. So prompt like, this is my question, these are the similar splits I'm getting based on the data. Can you answer that question using those splits? And that prompt is given to the large language model, which would return us the answer. So whole that thing happens in the Retrieval QA system. Now our question and answer system is ready. We can ask it questions. So before we do that, let me run this code. Okay, so our vector DB is ready now, and we have converted our chunks into a vector database. Now let's ask questions to the question and answer system which we have created. So the first question I'm going to ask is, which data types can be given as input to Gemini AI? So let's see what it answers. So it is saying Gemini models can take textual input interleaved with wide variety of audio, visual inputs, images, screenshots, PDFs, videos. So basically it is able to answer it correctly. Because Gemini model is a multimodal model, it can take different types of data sources as input, and our question and answer system is able to answer that question because now it has learned based on the PDFs which we have provided to it. Then let's ask a specific question. How is the performance of Gemini and GPT-4 on Python code generation tasks? So let's run this. So what it is saying is, on a new held out evaluation benchmark for Python code generation task, Gemini Ultra achieved the highest score of 74.9%. So again, it is able to get the correct answer from the data that we have, that Gemini Ultra's performance is 74.9%. So let's go to the next question. Next question is, how is the performance of Gemini Nano as compared to Gemini Ultra on MMLU benchmark? So it is saying that Gemini Nano has not been evaluated on the MMLU benchmark. Again, if you see the technical report or the research paper of Google DeepMind, you won't see the evaluation of Gemini Nano on the MMLU benchmark. So our question and answer system is able to understand that and able to answer the question correctly. Now let's ask some questions related to our second research paper, which was related to the large vision models. So the first question I'm going to ask is, what is video sequence? So it is saying video sequence is a natural form of visual sentence that is created by sourcing video data from wide range of existing data sets, and visual sentences of 16 frames are formed by randomly sampling the videos at 3 different strides. So again, it is able to refer to the PDF which we have given and correctly answer the question. Let's ask some tricky question. Can you teach me large vision model? Let's ask it to our question and answer system. So it is saying, no, I'm sorry, I can't teach you large vision model. It is giving us information about what is large vision model, and at the end it is saying you can read more about it in the paper introducing it from UC Berkeley and Johns Hopkins University. So it is saying that I won't be able to teach you LVM, but you can read the material which I am suggesting to learn about LVM. So this is how we have successfully created a question and answer system which is giving correct answers on the PDFs which we have provided. Now, if you have any other data set on which you want to create question and answer system, you just have to replace your PDFs at the top. So here, the path we are providing, right, from where we want to load the PDFs. So at this path, you just have to keep your PDFs, and this question and answer system would work on your data as well. And you would be able to create your own question and answer system. So I hope this was clear, and now you're confident about building your own Q&A system. And thanks for watching the video. I will see you in the next video. Bye-bye.